Thank you for having me here. you know, uh, 10 years ago in 2011, Jan van Dersen and his colleagues at the Mayo Clinic made a remarkable observation. This was a paper that was published in Nature, and they were interested in understanding whether senescent cells might contribute to diseases of aging. So as we age, across all of our tissues, we accumulate senescent cells. And as you know, aging is a primary risk factor for a number of different diseases. And so what Jan and his colleagues wanted to know is, are they contributing to disease progression? They made a mouse where they could either inducibly or chronically eliminate senescent cells. And what they found was that in these mice, not only at 12 months or 18 months did the mice look healthier, much healthier, that across tissues, various measures of age-associated pathology had been significantly reduced. Yeah, this is a lead article in Nature, and on that day, the ideas that led to Unity were conceived of. The idea was that if this is a fundamental mechanism of aging-associated diseases, and if we could find a way of targeting and eliminating senescent cells, this could be transformative across diseases. Sorry, I need to move this forward. Oh, sorry, I'm going the wrong way. So at Unity, we're focused on developing agents that are both senolytics and otherwise to change the trajectory of aging-associated diseases with the primary focus in ophthalmology and neurology. We're excited because right now we're in our first clinical studies in ophthalmology, and we have a number of data readouts coming up in the next few months and few weeks. And today I'm going to share you some kind of brand hot off the press clinical data from our first study. The lead program is UBX1325, which is a BCL-XL inhibitor that is designed to eliminate senescent cells from the retinal vasculature. It is in two studies, a phase 1 single ascending dose study, from which I'll be sharing 12-week data today after a single injection. And there's a phase 2A study in DME that we recently initiated that will read out 12-week safety and efficacy data in the first half of next year. I want to take a minute to just explain the therapeutic approach here because it is very different from most of the things that we've been hearing about today. So going from left to right is an illustration of accumulation of senescent cells in tissue. What happens is that under various stressors, including DNA damage or other environmental factors, there will be a subset of cells that will enter a state where they'll stop dividing, but they're highly metabolically active. These are the senescent cells shown in blue. Because they secrete factors that damage the environment, they can lead to recruitment of various inflammatory cell types and lead to further tissue damage and eventually lead to disease. Our goal is to develop senolytic agents that will perform a precision strike to get rid of senescent cells while not affecting nearby healthy cells, and thereby not only preventing disease progression, but allowing the restorative power of the tissue to reverse the trajectory of aging. So this is what we would like to be able to do, and our lead experiment is testing this in the eye. So over the past several years, we've accumulated data that indicate that in the eye, in the context of aging, and particularly in DME and AMD, there's an accumulation of senescent cells in the retinal vasculature. So illustrated at the bottom part of this panel is an example of blood vessels showing accumulation of senescent cells, shown in blue, that not only lead to loss of vascular integrity, but lead to inflammation of the eye. And we're developing agents to target those cells. So the reason we're excited about this approach is one of the examples of this is shown in this preclinical data set that shows with a BCL-XL inhibitor, not only do you get nice inhibition of BCL-XL in the eye that leads to activation of caspase shown on the bottom left in a disease model of eye, an OIR model, that leads to reduction in neovascularization and reduction in avascular areas of the eye. I think the right hand really illustrates, here's an example of an image being worth 1,000 words, that in the diseased eye, you see these big ischemic areas near the center of the eye with aberrant blood vessel growth to the top right. But after treatment with UBX1325, you see reduction in ischemic areas in the eye, as well as pristine blood vessels. So what happens when you take it into the clinic? So I'm going to just share some DME data today. Earlier this week, actually, Bob Bizical in a call shared this data, and we reported that at 12 weeks after single injection in advanced AMD and DME patients who had mostly failed anti-VEGF treatments and were considered no longer eligible for anti-VEGFs, that we saw significant improvements in vision and in structure in a majority of the patients. Let me just show you a couple of key examples, key data sets from that study. So this is where we are. So this is change in BCVA from baseline following a single intravitreal injection of UBX1325. I'm showing all the DME patients in the study so far, and you see that a vast majority of them show an improvement, rapid improvement in BCVA within a few days. Most importantly, that is then sustained. Once you get out to 4 weeks, 8 weeks, and 12 weeks, you sustain improvement. I want to draw your attention on the top right to the 10 microgram dose, which is the dose we're taking into the phase 2A study. Here you see those patients showing improvement about 10 letters. And for reference, just to kind of ground us, I've included in red X's data from the VISTA study, patients who got Eylea every month, right? So we're seeing, gains that are comparable to what we've seen before in an agent that is highly effective, suggesting that there's a potential for this to really lead to long-lasting efficacy after a single injection. I think the trajectory in 8 and 12 is very promising and suggests that that stability might continue. And the mechanism is such that if you eliminate the senescent cells, you've removed the root cause of the disease, and thereby you might get an effect that way outlasts the PK. The drug is removed from the eye within a week. So everything you're seeing at week 12 is a residual effect of that initial intervention. I'll just show you an example, a couple of examples of images from the eye, just to show you what the effects are in the eye. This is a DME patient, 5 microgram dose. You see reduction in fluid in the central field as well as in the adjacent areas. Here's an example of an AMD patient seeing fluid at baseline, and 8 weeks later, you see nice resolution of that fluid and improvement in retinal structure. I'll just wrap up by saying that we're really excited to have introduced a potentially new treatment paradigm that after a single injection could provide transformative, long-lasting benefit, and we'll be following this in the phase 2 studies. I'll just also mention in this last closing slide that we're looking forward to sharing 24-week data from this study before the end of the year, as well as a separate cohort of AMD patients that is currently ongoing. We're looking into starting a phase 2A AMD study towards the end of the year. I know many of you are involved in those studies, and thank you for your participation. I just also remind you, because I know most of you will be at ASRS as well, that on Friday, right before the opening session, we have a symposium where Bob Bisicle and Arshad Khanani will be moderating a session discussing this data and putting it in context. Thank you.